Hello everyone, welcome to Alacrity Explains Anatomy. Today we are going to be looking at the arcs of the foot. Some people pronounce it as arches of the foot. I don't know. But whenever you pronounce it, you know what we're talking about. So, the human foot is not flat. No, it's not a flat structure. It's designed as a semi-rigid elastic spring composed of bony arches. So, we have the foot. If you look at the foot, you see that there are arcs. The foot is not flat on the ground. So why do we need this? It serves weight distribution. It helps to distribute the weight of the body evenly over the plantar surface of the foot. It acts as a shock absorber. Shock absorption. It absorbs the impact of forces when you are walking, running, or jumping. It also serves propulsion, which is it acts as a rigid lever during the toe off phase of gait. It also serves adaptive function. It adjusts to uneven surfaces. When you walk on uneven surface, it helps to adapt. So these are the arches of the foot. So the main arches of the foot, they are formed by the tarsal and metatarsal bones held together by ligaments as well as muscles. They are not static. They flatten slightly under load and they recoil when they are unloaded, when there's no force, when there's no much force applied. So we have the medial longitudinal arc, we have the lateral longitudinal arc, and we have the transverse midfoot arc. Now, the medial longitudinal arc is on the inner side of the foot. That means we have on the medial aspect, just like the name, the medial longitudinal arc is on the medial aspect of the foot. And it is formed by the following bones: the inner side of the calcaneus, the talus, the navicular, the cuneiforms, and the metatarsals. The first, second, and third metatarsals. In that order, from posterior to anterior: calcaneus, talus, navicular, cuneiforms, metatarsals. The height, it is high. While for lateral longitudinal arc, this is our medial longitudinal arc. As you can see here, it is high compared to the lateral longitudinal arc. The lateral longitudinal arc, from posterior to anterior, we have the calcaneus, we have the cuboid, and we have the metatarsals, the fourth to the fifth metatarsals, while the height is low. We now have the transverse or midfoot, which is cuboid, consists of the cuboid bone, the cuneiforms, the basis of the metatarsals, and the height varies depending on how one is standing, and from person to person it varies in height. So that's that about that. So let's now look at the medial longitudinal arc. The medial longitudinal arc is the most important functionally. It has the keystone bone, which is the talus, responsible for weight. It transmits weight from the tibia to the talus, transfers weight from the tibia to the talus, and distributes it to the metatarsals in front and the calcaneus posteriorly. The shape, it is higher. The medial longitudinal arc is higher. It is more flexible and it is spring-like. It has structures that serve support function. These include ligaments and muscles. For the ligaments, we have the plantar calcaneo-navicular ligament, that is the ligament on the plantar aspect that connects the calcaneus to the navicular. Anatomical terms are such that from the names, some of them from the names, you'll be able to figure out what they represent or where they are located. Plantar calcaneo-navicular ligament, also called the spring ligament, is a ligament on the plantar aspect of the foot, and it is joining the calcaneus and the navicular bone. It is the most critical and supports the head of the talus. Now, the next ligament we have is the long plantar ligament, which is superficial and runs from the calcaneus to the basis of the metatarsals. We also have the plantar aponeurosis, which is thick in nature. It's a thick fascia that serves a windlass mechanism. Now, for the muscles, we have the tibialis posterior, which is a primary dynamic support and it suspends the arc. We have the flexor hallucis longus as well as the flexor digitorum longus. These are important muscles that provide support to the medial longitudinal arc. We also have the intrinsic muscles of the foot. The adductor hallucis, the quadratus plantae. They all serve supportive function to the medial longitudinal arc. This is the medial longitudinal arc. We said from posterior to anterior, we have the calcaneus, we have the talus, we have the navicular, we have the cuneiforms, which are three cuneiforms, and we have the metatarsals, these first, second, and third metatarsals. Now let's look at the lateral longitudinal arc of the foot. The keystone bone here is the cuboid. The cuboid is the major bone in this arc. Look at this is the lateral longitudinal arc. You have from calcaneus here down to this point. You see that if you compare it to the medial longitudinal arc looks higher. The shape, it is lower, flatter, and stiffer, primarily for weight bearing and stability, but not for shock absorption. Shock absorption is not a function of the lateral longitudinal arc. Support, we have the long plantar ligament, which is shortest in foot. We have the short plantar ligament, which is the calcaneocuboid, between the calcaneus and the cuboid. We have muscles which provide support. Here we have the peroneus longus and the peroneus brevis. Peroneus longus and peroneus brevis can also be called the fibularis longus and fibularis brevis. Now this is the lateral longitudinal arc. You see the calcaneus, you see the cuboid, and you see the fourth and fifth metatarsals. So let's look at the transverse arc. The transverse arc is dome shaped across the midfoot. It is what? It is dome shaped across the midfoot. It is dome shaped and like half of a cylinder. The components, we have the cuboid, the three cuneiforms, and the bases of the 5 metatarsals. It's in cross section, which is the image you are seeing here, looking at the transverse arc in cross section of the foot. You see from medial and lateral rays, they drop. The middle rays peak at the middle. It peaks at the middle. If you see, it peaks at the middle, while on the lateral side the arc drops. So that's what it is. It disappears in flat foot. Whenever there is a condition called flat foot, the transverse arc also disappears. Now for support, what are the structures that form support? We have the deep transverse metatarsal ligament. We have the adductor hallucis longus. The adductor hallucis. We have the peroneus longus, which pulls the first ray down, deepening the arc, helps to deepen the arc. Now, what are the clinical correlates? We have pes planus, also called flat foot. It is a condition that occurs when the medial arc falls. The foot now appears flat. The talar head medially prominent, and the medial longitudinal foot is the part of the foot affected. You see that the foot is flat, as you can see in this image. There is no arc on the medial aspect. The foot is flat. It's a condition called flat foot. Commonly when there is a loss of the keystone, which is by the talus, so the foot becomes flat. There could be compression of neurovascular structures, nerves, and arteries that are located in the plantar surface of the foot. We have pes cavus, or high arc, which is an excessively high rigid arc, often neurological. There is poor shock absorption, and the medial longitudinal arc is also affected. This is our pes cavus. This is the pes cavus. You see how high it's unusually high, and you say that it is what? It is often neurological. We have plantar fasciitis, which is a micro tear at the calcaneal origin of the plantar aponeurosis. At the origin of the plantar aponeurosis, there could be a micro tear, which is common in obese patients as well as runners, and the medial longitudinal arc can also be affected. This is plantar fasciitis. There is a micro tear at the origin of the plantar aponeurosis. We have metatarsalgia pain. Metatarsalgia is pain under the metatarsal head due to a transverse arc collapse. Whenever there is a collapse of the transverse arc, which we showed in this image earlier, whenever this arc collapses, there could be pain felt around the region. This is the area of pain felt around the region of the metatarsals, the base of the the base of the phalanges as well as that of the metatarsals. So you have pain felt at that region. So in summary, you know that the talus is the keystone of the medial arc, the cuboid is the midstone, the keystone of the lateral arc, the spring ligament and the tibialis posterior are the most important support of the medial arc, spring ligament as well as tibialis posterior. The plantar aponeurosis is very essential for wine glass mechanism, converting the foot from a shock absorber to a rigid lever. And loss of either of the spring ligaments or the tibialis posterior function can lead to acquired flat foot deformity, which we regard as pes planus. So that will be all for this video. Thank you for watching. Don't forget to like, share and subscribe.